And now we again have user ID, and this is the user. And now we have assistant message, and this is the assistant. So this is the apply chat template thing that is helps here. So this is the apply chat template, and this is the what we are going to pass it. So let me just go over again this thing. This apply chat template applies the chat template on the conversation and generates it. So suppose it had been a Qwen model. Hello everyone, welcome back to my channel. Today we are going to learn everything about fine-tuning large language models on a dataset. We are going to learn about the code, the definitions, how exactly to fine-tune models in general, what are the techniques that we use, and which is the best technique, what are the limitations, pros, cons, and everything. We're going to learn every detail of the code that I'm going to write on the screen. And so code along, understand everything, and this will solve 99% of your problems you've ever had. So I don't want to waste your time. So here's the list that we are going to discuss today. So let's dive right in. Okay, so the first thing that we're going to do is learn supervised fine-tuning. It's a method to improve and customize pre-trained LLMs. So it basically, what does it involve? It retraining the base models on a smaller dataset of instructions and answers. So the main goal is not to learn new knowledge or anything. It's just to transform a basic model which predicts text into an assistant that can follow instructions, answer questions exactly however we want. For example, SFT can enhance the model's overall performance because a model, it is trained on trillions and trillions of tokens. And it's very difficult because suppose we want a model that only does doc generation, that only does PDF explanation, that does video understanding, whatever it is. So we want our model to be specific to that particular task, because consider any kind of industries. These industries, for example, there's an industry which does Excel generation, Excel explanation, Excel documents, Word documents, whatever it is, PPT generation. These are all specific tasks that we want our model to do. And that is where fine-tuning plays a massive, massive, massive role. So you need to understand what's the use case first. So use case is not to add new knowledge, it's to adapt it to specific tasks and domains. Okay, so let's take an example. For example, suppose about doc generation. You remember the model that I used for doing a YouTube model for making a video summarizer for LLMs. So what did I do there? I used a normal LLM and I used its knowledge base to do that. But if I had done fine tuning, then my performance would have been so much greater. So now in today's video, we're going to do that, exactly that. However, remember this, SFT has limitations. I told you it works best when leveraging knowledge that is already present in the base model. So for example, if you wanted to make a coding agent that is going to do autocomplete, that is going to do chat, edit, whatever, agent, you need to use a coding model that has already been trained on trillions of coding tokens, and it has mainly coding knowledge. Which would that be? Qwen 2.5 Quarter 32B, obviously. But that's not our concern right now. What I'm saying is that if you want a model that does a particular job well, you need to ensure that the knowledge that is needed for the job is already present in the base model. So learning completely new information is like an unknown knowledge. It can be challenging and it leads to many more hallucinations. So remember that. This is very important. Use a model which for a particular task that it has already the knowledge on it, inside it. Okay, so the popular SFT techniques are three. So there is one is the full fine-tuning, which is crazy, which involves retraining all the parameters of a pre-trained model on an instruction dataset. This can provide the best results, but it's not any of use because we don't have that many GPUs. Even companies don't have that many GPUs. We don't have that many GPUs. We don't have that much money. We don't have that much resources. We don't have that much time. So forget about it because it's easily useless. And it is very dangerous because it can lead to forgetting the original information as well. So no, this is something we're not going to do. Now comes low rank adaptation, or LoRA. You must have heard about it so many times. So let's dig deeper into this. So it is actually a popular parameter efficient fine-tuning technique. So what does it do? It basically freezes the actual weights, original weights, and then introduces small adapters. What are these adapters? It's low rank matrices at each targeted layer. So there are many layers in a model. So this allows the LoRA to train a number of parameters that is drastically lower than the full fine-tuning, less than 1%. And it reduces both memory usage and training time. And this method is also non-destructive because your model will not forget everything that it has learned. So it can be switched or combined, and it has extra powers. So it has not forgotten its original knowledge, and it has extra powers because it knows how to use that knowledge for a particular weapon. Now comes the QLoRA. QLoRA is quantization-aware low-rank adaptation. It's an extension of LoRA that offers even greater memory savings. It provides up to 33% of additional memory reduction compared to the standard LoRA. And it's very useful when GPU memory is constrained. So, which is of course your case because you don't have GPUs, you just have whatever is available in Colab or whatever is available in your, if you're in college, then you whatever is available in your servers or whatever is available in your local laptop. That's it. So QLoRa, we are going to use QLoRa today, and QLoRa is the most common thing that is used, and it's very efficient. You don't need to worry about its accuracy or anything. Now comes what library we are going to use. So we are going to use the Unsloth library. It's more compatible with Llama models. So we are going to basically fine-tune today Llama 3.1 8B model. So that is why we are going to use the Unsloth library. Llama models are best when it comes to fine-tuning. You have Unsloth library, which provides 2 times faster training and 60% memory use compared to other options, which makes it an ideal in like Colab or in your local computer. So this is very important. And we're going to QLoRa fine-tune it on the FineTOM 100K dataset. So what this dataset does is basically an instruction dataset. Like we have some question, we have some answers. You can use whatever dataset you want. I just chose this because, well, it's there on the internet. Use Hugging Face. I'm telling it again, use datasets that are available on Hugging Face. There are millions of datasets that are available on Hugging Face. Use that. Do not try to make your own dataset unless it's absolutely necessary. Use the dataset available on Hugging Face. It will make your life so much easier. Just believe me. And use Hugging Face, FineWeb, Edu classifier. So that is the largest dataset available on Hugging Face that has knowledge of everything. So basically, this FineTOM 100K dataset is a small fraction of this huge dataset because I don't want to train on millions and millions of data points. You can do that, but based on your use case, this is just a sample. And we are going to just train it for 60 steps. So you can change however you want. You can experiment, do whatever you want. But yeah, but do code along. Do hands-on coding along with me. Okay, so we are going to use GPU here. We are going to need GPU here. So this is Google Colab. Go inside it. And then check here. This is enough. And then change runtime type. Go to use T4 GPU. That's it. Great. Now you're all set. Let's start coding. All the best. Code along with me. Don't just sit there. Code along with me. Okay, so the first thing is definitely installation of every library. So as I told you, we are going to need Unsloth. We're going to need transformers. We're going to need TRL. So these are all the libraries that we generally use. Transformers we use for attention layers and downloading the model and inferencing from the model. Same for TRL. And Unsloth is specifically we are using for Llama model, since we are going to today fine-tune Llama 3.182. Great. So this is done now. Let's restart the runtime. As it says, restart session. Great. Now it's restarting and it's done. Let's hide the output. Okay, now we're going to import. So we'll need Torch. Torch is the single most important thing for all fine-tuning models, anything to do with large language models. So next thing is going to be from Unsloth. Yeah, we are going to import fast language model. So this is the model type that we are going to use because it's optimized. We're not going to use the auto language model because that's normal, but we're going to use the fast language model. Okay, I hope you're with me so far. So from datasets, import load dataset. Simple, it's just going to load the dataset. Now going to do from TRL, we are going to import the SFT trainer. Why are we importing the SFT trainer? Because it is the supervised fine-tuning model that we are going to use. So be careful when doing the autocomplete. So from TRL, import SFT trainer because SFT trainer is the one that we're going to use here. There's other methods as well, DPO trainer, but that I'll cover in next video. With both SFT and DPO are pretty useful in day-to-day lives. And we're going to use the SFT trainer. Okay, so now comes from transformers. Import training arguments. Great. Now the next thing is from Unsloth dot chat templates. We're going to do is import get chat template. Why do we need this? I'll come to it in greater detail. But basically, we are going to transform our messages such that it's able to understand the chat template. What do I mean by that? So basically, instruct dataset, if you know what we do, we have system message, the OpenAI API. So we have the system message, we have the user message, and we have the system message, right? So how do we give it? We give it in the form of a dictionary. We have the system message, a string. We have the user message, which is a string. And then when it gets passed in to the model for inference, for training, whatever, So in that case, obviously it cannot understand dictionary format. It has to understand string format because it's going to predict the next token. That is why this chat template, apply chat template, get chat template, what does it do? It basically transforms that entire string, however it is present there, into a proper string, single string that is going to be passed in for training or for inference. We'll come into it in greater detail, so stay tuned. And we're going to use standardized share GPT because that's the format of the dataset that we're going to use. I'll come in detail, more details. So this is done. Now, next thing that comes is we're going to download the model and the tokenizer. We're going to do is fast language model from pretend. Okay, so this is just autocomplete, but what we're going to do is, yes, sorry. Yeah. Here what we're going to do is, we're going to do model name equal to Unsloth Llama 3.28, let's do 3 billion instruct. That's it. And next we are going to do max sequence length. Why are we doing this? So max sequence length is basically the maximum sequence that the model can process. So here we are going to put in 2048. So 2048 is actually the context window size for this model. So what do I mean by that? So for example, the amount of tokens that we can pass in a single turn of the message. For example, in a conversation. So suppose we are going to send in a huge document, and then we are going to send in more assistant messages, more user messages, follow-up questions, everything. So all of this we're sending in, right? So all of this should be within 2048 tokens. This is very important. And also the response, the assistant response should also, but everything together should be within 2048 tokens, which is enough, definitely. But yeah, it's just to make your lives easier. You can experiment with it more. You should experiment with it more. Not you can experiment with it more, you should experiment with it more. Okay, and the next thing is load in 4 bytes. 4-bit, yeah. 4-bit equal to true. Why are we doing this? Because, let me come to it. Why are we doing this? This is very important because, let's see. Let's download this. As it's downloading, we are going to discuss. So why are we doing this? Because we are going to use 4-bit quantized technique. So what is it? Like the model is like huge, right? There's so many different parameters, so many different, huge, like 3 billion parameters. It's not easy for a model to know that. So that is why this enables 4-bit quantization for loading the file model. This basically significantly reduces the memory. And obviously we don't have memory much. We have GPU using only one GPU here on our collab. So that is why we don't have that much GPU. So compared to full precision, 32-bit or 16-bit, so we are going to use 4-bit. It creates a small amount of accuracy for a much better memory efficiency. We often use it in our company as well. So yeah, that's very important. Now that we have seen that this has been loaded, let's move on to the next part. So what are we going to do? Model equal to fast language model dot get PFT model. I'll explain everything. Don't worry about it. Get PFT model. So we're going to pass in the model. We're going to pass in R. What is R? I'm coming. Okay, before doing it, let's discuss. So basically, what does it mean? So basically, this creates a PFT version of the model. What does PFT mean? Parameter efficient fine tuning model for the language model. So basically, it allows fine tuning large models without modifying all the parameters. So this is basically the QLoRa thing that I was talking about. It does not modify all the parameters because that would mean that is destruction. Don't do that ever. Use LoRa or QLoRa. We are going to use QLoRa. So this saves memory and computation while achieving great accuracy. And now comes R equals Stin. What is R? This is basically the rank parameter for LoRa or low rank adaptation. So higher rank here, we are using 16. 16 is the perfect combination from efficiency and losing information and memory efficiency and effectiveness, basically. So higher rank means that more capacity to learn, but it uses more memory. So we don't want to use more memory. Just use 16. It's best. And if that also goes above your memory limit, then use 8. It's okay. 16 is a common choice. And now comes the target modules. Let's see. What does it mean? Target modules. So target modules are going to be, we have QProj. What is that? Don't get scared. I'm going to explain each and everything. Don't worry about it. First, let me write this down. So VProj Now comes OProj. Now comes GateProj. Basically, proj is short for projection, but yeah, I'm just saying this so that you know what to do. No need to memorize, just learn and understand and explain. Be able to explain to your interviewer, to your college professor, whoever, and you are good. Okay, so let's discuss what are these. So these are the target modules. So these are the specific layers which are being fine-tuned. So QProj is the query projection and attention. So I'll share a link in the description, which is basically describes the attention layers in great detail. So these are what do I mean? So attention is all you need. This is the most famous paper, as you can see. So this paper actually got very famous, and this paper led to the modern day GPT models, Claude models, everything is because of that paper. So that describes how this attention is being calculated. So there are layers, and then each line is predicting the next token. So how is it doing that? How is it able to remember everything from back then? So this is why this attention comes into play. And these are all the different attention layers that are used in fine tuning. So if it was full fine tuning, it would have changed everything. But no, but now what we're going to do is we're going to change the query projection and attention. We're going to change the key projection. Q is the query projection, K is the key projection, V is the value projection. Basically, it's like a dictionary form. We have query, key, value, and O is the output projection. G, gate proj is the gate projection, and we have upward projection and we have downward projection. And these are all like very important things. So you have to understand these in great detail. So this setup is using LoRa, which adds like small trainable rank decomposition things to these, as I said before, to these key value matrices instead of fine tuning the entire thing. So this speeds up training by a lot. So I cannot delve into more detail here, but I'll make another video explaining everything and even more details about all this. But do try to read that paper. You will understand everything. But for now, just remember, this is the code that is you're going to use in all hackathons. You're going to use in interviews. You're going to use in you're going to use in OA. You're going to use in your company even. So remember this code. This is very important. So that's it. Makes sense. Okay. So now let's move on to the next question, next part. Now we're going to get the tokenizer. So now we're going to do is tokenizer equal to get chat template. Get chat template and tokenizer. Chat template would be the Llama one. That's it. This is the tokenizer. Now we are going to get the data set on which we are going to do the fine tuning. So yeah, almost similar, but the data set is going to be, as I said, LaBone / fine. Let me see that. LaBone. This one. Exactly. This is the one that we are going to use. Let's go through that. Let's not hurry. Let's go through that. So as you can see, what does it have? Let's see this one. So it's like it has 100K rows, which is more than enough for right now. Yeah. Let's see. From human, the value is going to be explained what this are. And then from assistant, what are we going to get? It describes everything that we wanted to know. And then from assistant, it describes everything. Yeah. From GPT, value is this. So this is what we are going to train the model to behave like GPT. Llama is definitely nowhere near GPT. Come on, let's be honest. So obviously, we are going to use it to see how much closer to GPT can we get. Now that we have here, let's go. Let's get the data set. We have got the data set. Now we're going to standardize this. It's in the share GPT format. Check what GPT format it's there in. Do this standardized share GPT that we just now like data set. Okay. I had not defined this yet. That is why this happened. But yeah, now we'll see this. It's going to do standardization. And let's see what dataset actually looks like after this. Done. It's very fast. See, since it's doing via Unsloth, it's very fast. It's conversation, source, and then score. Great. If you really want, then we can see one example. Yeah. So the content is this. See, this is the content is this, the role user, and this is the assistant content. So this is the user content, and this is the assistant content. Perfect. Great. This code doesn't really mean much, but yeah, whatever. It's sort of supposed to help us during the loss, but even if you don't have that, it's fine. It's okay. Okay, so let's do this. So now we are going to do something interesting. We're going to map the dataset in the format that is going to be useful for Onslaught fine-tuning, SFT fine-tuning, so supervised fine-tuning. Yeah. Okay, so let's see what is happening here. So we're going to do lambda examples. And this is going to be, let's do text. And text is going to be tokenizer dot apply chat template to all the conversations inside this. And you don't want it tokenize equal to false. Why is it tokenize equal to false? Come on, you know why is it tokenize equal to false? So otherwise it will just give us the tokens. We don't want tokens, we want the string. So that is why tokenize equal to false. It's very important. Remember this is very important. And for obviously for convo in examples, conversations. That's it. It looks great. Now we are going to do batch equal to true. Definitely do not ever do it without batching because it will take forever. Just do batching. It's going to take some time. Let's see how the dataset looks like after this. Source text. Now we have an extra indicator text. Let's see. Text is going to be, yeah, see, this is what I was saying. So you apply the chat template. See, these are the tokens that you have. So this is system message. We are giving it inside this, and this is the system message that is going to be passed in based on llama, whatever llama is, and then Onslaught llama, whatever, and then end of token. And now we again have user ID, and this is the user. And now we have assistant message, and this is the assistant. So this is the apply chat template thing that helps here. So this is the apply chat template, and this is the what we are going to pass in. So let me just go over again this thing. This apply chat template applies the chat template on the conversation and generates it. So suppose it had been a Qwen model. Let's say, for example, if you remember the AIR 12 hackathon that we discussed, linked right here. So that one that we discussed, there he had used fine-tuning on Qwen model. So for that, in that case, the chat template is different. This is the llama chat template. That will be a Qwen chat template. So I can tell you, Qwen chat template, we don't have start header ID. We have IM underscore start, and we have IM underscore end. So it's all different models. However, they are trained. These tokens have special meaning for these models, and this will help significantly when we are trying to train. So you have to remember this. You have to provide the chat template. Great. I hope this clears up everything. Now let's move on. Now we're going to train. We are almost there. Training and then inference. That's it. We're done. It's very simple. It's very simple. Just don't get overwhelmed. I mean, seriously, if you just learn through this, you can easily do it like this. Do hackathons like this. AIR 12, AIR 1, nothing will matter. Interviews as well, just like you're going to be able to solve everything. Trust me on this. Okay, now we're going to do the SFT trainer. So this is the first thing. Next thing is let's take this. Next thing is the train dataset. So obviously this is the dataset that we did, and this is going to be used in training. Now the text field that we are going to use is the text, basically, whichever this one. We don't need to delete the other fields. It will automatically be ignored. The one thing that only matters is text. That's it. And we have max sequence length is 2048, as I said, context window. And we have the tokenizer is already there, so we don't need the tokenizer. So we're just going to put in the arguments. So this is very important. Remember this. These are the training arguments. Let's see. So first thing is coming is the per device train batch size. Let's give it 2. It's going to be faster. Gradient accumulation steps. Okay, so what does gradient accumulation steps mean? Let's dive into this. So what is it exactly happens when we are doing this training step? So with each step, so let's say we have max steps equal to 60. We're not going to do for many steps because we want it to finish. And you can add it any number of test steps as you want. That's okay. So let's discuss the gradient accumulation steps. So what it's going to do for each step, out of 60 steps for each step, is going to load 2 examples from the training data, from the data set, because our train batch size is 2. It's going to perform a forward pass. It's going to calculate the loss. It's going to perform a backward pass. And then repeat this thing, repeats the entire thing 4 times, because gradient accumulation steps is 4. So how many times we are accumulating the gradient is this. And it's going to update the model weights after this and then log the progress. So let's see. So we have warm-up steps equal to 5. We're going to have max steps equal to 60. And we're going to have learning rate equal to 2e minus 4. Okay, let's just do tab and then we'll change. So learning rate is 2e minus 4. We have FP16 equal to true, yeah, but maybe sometimes happens that it's not there. So what we're going to do is not torch dot CUDA dot is BF16 supported. Then you use FP16. Otherwise, always prefer to use BF16. It's going to save memory so much. So it's nothing much. It's just a way to basically load the weights and train the weights. So it's okay. You don't need to dive deep into this. It's just brain floor 16. Just remember this, and this is FP16. So brain floor 16 is the better choice always. Torch.CUDA is BF16 supported. Just check once. And you have logging steps is 1. We are going to always log the steps. We are going to have the output directory as outputs. And we're not going to put in any kind of optimizer. Let's see what it does by default. And this is not needed. So this is the trainer. We're going to load everything and it's going to initialize the trainer. Now the next thing is very simple. I know you all can guess this. This is just simply trainer.train. That's it. Now the next thing is, it might happen that this stops, collapses, I don't know, collapses, whatever, anything can happen. So just ensure that you save the model .save pre-trained as fine-tuned model. Okay, so this is going to take some time. We'll come back after this. Okay, so see, this kind of errors can happen. So let's try to debug. So what happened here? It's saying that our model is not is PFT model. So definitely this is impossible because we have converted here PFT. Let's see, let's go through it one by one. This one we had already done. This is done. This is done. See, even like ML engineers like me, this can happen. It doesn't matter your seniority. It doesn't matter how young you are, how old you are. These mistakes are common. So let's do this. This is the wrong thing that we did. We did not run this. So the model is the old model only. This model, which is not PFT model. And in that case, it cannot be done. See, every step is so important. We're going to run all of the steps again and again start running this. This time this should work. So I would say like discussing errors, going through errors, running into errors is all a part of process of growing. Now you know this error, you know why it's coming. You actually have more knowledge because this error came. Because you know that where exactly the PFT model is being used. Not in any of the earlier steps, but in this step. Because this SFT trainer is going to be using this PFT model only. Otherwise, it's not going to be able to work. Next step would be trainer.train and then model.save pre-trained. Now it has started the training. It's going to ask for an API key. So I'm going to blur this. But go to that site happening in your model so that when you go in this site, you are able to use it. It's absolutely free, so don't worry about it. Just go to the site, get the API key, put it there, and it will start your run. As you can see, Runner is saved locally here. So it's going to be saving that. so that if something happens, you're not going to lose the data actually. You're not going to, you can go back to the checkpoint till which your data got fine-tuned. See, Anslath is going to smartly offload the gradients to save my RAM usage. Just started the training. Till 60, it's going to train. Yeah. Out of 60. After this is very less of like worrying, because it's just going to be simply inferencing. That's it. I'm going to show you how to inference, because that is very important. When you're trying to do hackathon, just training won't help. You need to also be able to inference. Okay, great. Now that this is done, everything is perfect. We have saved the model, and now we are going to infer. This is very simple, just to say very simple step. I'll explain as we go along. So inference model and inference tokenizer use the same way that you have used to download it. So it's going to be fast language model dot from pre-trained, and it's going to be model name equal to, you know what to do, dot slash fine-tune model, because you just now saved it. Perfect. Now the next thing is max sequence length. Keep the same thing, 2048, because I think the default is 4096, so it's important to set it every time. It's not going to change. And definitely load in 4-bit. 4-bit equal to true. That's it. Let's do this. Perfect. And now the next thing is basically, let's start writing. Now the next thing is basically text prompts. Text prompts is going to be, let's have a single prompt. So let's say, what are the key principles of, I don't know anything, investment, let's say. That's it. Let's keep one prompt and then let's see what happens. Now we are going to do for, you can add anything you want. That is why I'm keeping this loop. Text prompts. What are we going to do? So we are going to first format the prompt. Well, otherwise it's not going to work. How we're going to do that, I hope you know now. Chat template. Yes, exactly. Perfect. Yes. So apply chat template. We are going to apply the chat template like this. Let me see. And here in here, we are going to do it like, let me see. Let's go here. Let's go this. And here what we're going to do, you know what we're going to do. You know what we're going to do, right? So we are going to do role user. Perfect. See. But this is so wrong. See, just look at it. How wrong it is. Autocomplete here in Colab. It's so trashy. Oh my God. You just now saw what they did. Okay. So let's see, user and content is prompt. Here you go. We have the formatted prompt. Now what we are going to do is the model inputs. Now we are going to convert this into the model input and we are going to use it. Inference tokenizer. And this is going to be my formatted prompt. And we're going to do return tensor equal to pt and dot to CUDA. That's it. What does it do? So basically it changes the input format, tokenizes the input format. We are going to return as a tensor. That's it. And now we are going to do the generated IDs. So these are the output IDs that we are going to generate. So this is going to be inference model dot generate. So remember this format, use it everywhere. Keep a copy of it. I'm going to share the notebook, so don't worry about it, but do type it out so that you know what to do when you're doing hackathon, interviews, college exams, whatever. Model inputs. And then it's going to be how many new tokens you want. Max new tokens. Let's say we want 512. You can change however you want. You can change whatever you want. It's all right. And let's say temperature, temperature. So let's keep temperature 0.7. If temperature is 1.0, then it's completely random output. And if it's 0.0, then it's very deterministic. So it's just to add a new flavor to the language. I'm doing this and sampling, do sample equal to true, because we want it to choose among different kinds of samples. We don't want it to be like same thing and very deterministic. It's okay to innovate. Pat token ID is going to be inference tokenizer dot not EOS token ID, it's going to be Pat token ID. That's it. That's it, that's it, that's it. Awesome. We are almost there. And I don't know when this came along, but we're not going to use it. We're going to use our own thing. Use what I'm doing it. You're seeing the result, use it. I'm seriously telling you. Trust me, I know what I'm doing, and I would advise you to do it. Dot batch decode, and we're going to put in the generated IDs, and we're going to skip the special tokens. What the special tokens mean, like PAT token and EOS token and everything, just skip it because we don't want it to come up here. 0 because the first thing that we wanted here. And now we're going to do a print response. That's it. Okay. And probably did something wrong here. Yep, this is going to be returned tensor. You can also do explain error here, so it's going to help you. But since I know what I did wrong, I'm going to just do this. And we'll see. Let me see, did it change? Yes, it changed here. You have everything at your fingertips. Just do it. Really, just do it. Return tensors. I know what I went wrong, so that's okay. See, it gave the answer. We have system, this user, what is the question, and then assistant is this. It gave all the 10 key principles of investment. Perfect. And yeah, that wraps up everything. I would encourage you to do this to solve the problem that I shared and try your fine tuning on your own. And let me know in the comments or drop a like. Definitely drop a like and subscribe. More such videos are coming along. Okay, take care. Bye.